When selecting a timer for extended on and off cycles, several options exist. Electromechanical timers offer a robust, cost-effective solution. The Intermatic T900 one-time features an interval timer with 24-hour operation. It can be set for on and off durations of up to 24 hours each and costs around $20. Gardener's Supply Toggle Timer offers two timed intervals, each up to 24 hours in duration. It can be used for on/off cycles or repetitive cycles, with a cost of around $25. Electronic timers provide more precise control and longer durations. The Agiro 1130, a digital timer, provides independent on and off times with a maximum duration of 99 hours for each. It features a large LCD display for easy programming and costs around $30. The G15310 programmable timer offers 7 daily programs with multiple on/off events. It can accommodate durations of up to 24 hours per event, costing around $25. If these options don't meet the specifications, consider a customized timer. A qualified electrician can design and build a custom timer circuit to meet the requirements. However, this option may be more expensive. Also, when using a timer, a relay can be used to handle higher loads if the timer's output is not sufficient. When selecting a timer, ensure that it allows for precise adjustment of both on and off times. Also, some electronic timers may have higher standby power consumption, which could be an issue if the timer will not be used frequently. When dealing with electrical components, safety should always be prioritized. Firstly, disconnect the power supply to the circuit before working on any electrical connections. This will prevent accidental shocks and ensure a safe working environment. Secondly, use insulated tools specifically designed for electrical work. These tools provide an extra layer of protection against electric shock. Thirdly, carefully follow the manufacturer's instructions when installing and wiring the timer. Incorrect wiring can lead to malfunction or even damage to the equipment. Fourthly, if working with mains voltage, such as 120 volts or 240 volts, exercise extreme caution. Double-check all connections and ensure they are properly secured. Fifthly, if unsure about any aspect of the installation, consult a qualified electrician. They have the expertise to handle electrical work safely and efficiently. Sixthly, test the timer and the connected circuit after installation to verify that everything is working correctly. Use a multimeter to check for proper voltage and current levels. Seventhly, regularly inspect the timer and wiring for any signs of wear or damage. Replace any damaged components immediately to prevent potential hazards. Eighthly, keep the work area clean and free of clutter. This will help prevent accidents and make it easier to work on the electrical connections. Ninthly, wear appropriate personal protective equipment such as safety glasses and gloves to protect against potential hazards. Tenthly, familiarize yourself with local electrical codes and regulations. Ensure that all work complies with these standards. In addition to considering the timer options, understanding the load requirements is crucial. The load refers to the electrical device or circuit that the timer will be controlling. Firstly, determine the voltage of the load. Ensure that the timer is compatible with the voltage of the load, whether it's 120 volts, 240 volts, or another voltage. Secondly, calculate the current draw of the load. This is the amount of current, measured in amps, that the load will draw when it is operating. Thirdly, choose a timer with a current rating that is equal to or greater than the current draw of the load. This will ensure that the timer can handle the load without overheating or failing. Fourthly, consider the type of load. Some loads, such as motors or inductive loads, may require a timer with a higher current rating to handle the inrush current when they start up. Fifthly, if the load is a high-power device, such as a water heater or an air conditioner, consider using a relay in conjunction with the timer. The timer can control the relay, which in turn controls the high-power load. Sixthly, check the timer specifications for any limitations on the type of load it can control. Some timers may not be suitable for certain types of loads, such as electronic ballasts or LED lighting. Seventhly, when wiring the timer to the load, use appropriate wire sizes and connectors. Follow the manufacturer's instructions and local electrical codes. Eighthly, protect the timer and wiring from moisture and environmental factors. Use a weatherproof enclosure if necessary. Ninthly, regularly monitor the timer and load for any signs of overheating or malfunction. Address any issues promptly to prevent further damage or hazards. Tenthly, keep a record of the timer's specifications, wiring diagrams, and maintenance history. This will be helpful for troubleshooting and future reference. Furthermore, consider the different types of timers available and their specific applications. Firstly, mechanical timers use a clockwork mechanism to control the timing intervals. They are typically simple and reliable, but may not offer the same level of precision as electronic timers. Secondly, electronic timers use electronic components to control the timing intervals. They offer more precise control and can be programmed with complex timing schedules. Thirdly, digital timers use a digital display and keypad for programming. They are easy to use and offer a wide range of features. Fourthly, astronomical timers use a built-in astronomical clock to automatically adjust the timing intervals based on sunrise and sunset times. They are commonly used for outdoor lighting applications. Fifthly, repeat cycle timers are designed to repeatedly cycle on and off at predetermined intervals. They are used in applications such as process control and automated systems. Sixthly, delay on timers delay the start of a load after the timer is activated. They are used in applications such as motor starting and sequential control. Seventhly, delay off timers keep a load energized for a specified period of time after the timer is deactivated. They are used in applications such as ventilation systems and security lighting. Eighthly, interval timers energize a load for a specified period of time and then de-energize it for another specified period of time. They are used in applications such as irrigation systems and laboratory equipment. Ninthly, programmable timers allow you to program multiple on and off events for each day of the week. They are used in applications such as lighting control and HVAC systems. Tenthly, wireless timers can be controlled remotely using a smartphone or other wireless device. They are used in applications such as home automation and remote monitoring. In addition, power consumption is a critical factor to consider when selecting a timer, especially if it will be used frequently. Firstly, check the timer's specifications for its power consumption rating. This is the amount of power, measured in watts, that the timer consumes when it is operating. Secondly, consider the timer's standby power consumption. This is the amount of power that the timer consumes when it is not actively controlling a load. Thirdly, if the timer will be powered by a battery, choose a timer with low power consumption to extend the battery life. Fourthly, if the timer will be powered by mains voltage, consider the cost of electricity and choose a timer with energy-efficient features. Fifthly, some timers offer power-saving modes that can reduce power consumption when the timer is not actively controlling a load. Sixthly, consider using a timer with a built-in energy meter to track its power consumption over time. Seventhly, when comparing timers, look for models with the Energy Star label. These timers meet certain energy efficiency standards. Eighthly, avoid using timers with unnecessary features that consume extra power. Ninthly, regularly monitor the timer's power consumption and adjust the settings as needed to optimize energy efficiency. Tenthly, consider using a smart timer that can automatically adjust its settings based on real-time energy prices or usage patterns. Moreover, understanding the different wiring configurations for timers is essential for proper installation and operation. Firstly, single-pole, single-throw SPST timers have one input terminal and one output terminal. They are used to control a single circuit. Secondly, single-pole, double-throw SPDT timers have one input terminal and two output terminals. They can be used to switch between two different circuits. Thirdly, double-pole, single-throw DPST timers have two input terminals and two output terminals. They are used to control two separate circuits simultaneously. Fourthly, double-pole, double-throw DP/DT timers have 2 input terminals and 4 output terminals. They can be used to switch between 2 different sets of circuits. Fifthly, 3-way timers are used to control a load from 2 different locations. They require special wiring configurations with 3-way switches. Sixthly, 4-way timers are used to control a load from 3 or more different locations. They require special wiring configurations with 3-way and 4-way switches. Seventhly, when wiring a timer, always follow the manufacturer's instructions and local electrical codes. Eighthly, use appropriate wire sizes and connectors for the voltage and current of the circuit. Ninthly, clearly label all wires and terminals to avoid confusion. Tenthly, test the wiring thoroughly after installation to ensure that the timer is working correctly. In addition, adjustability is a key aspect to consider when choosing a timer for specific applications. Firstly, consider the range of time settings that the timer offers. Ensure that the timer can be set to the desired on and off durations. Secondly, check the resolution of the time settings. This is the smallest increment by which the time can be adjusted. Thirdly, look for timers with easy-to-use controls for adjusting the time settings. Fourthly, consider timers with multiple time ranges to accommodate different applications. Fifthly, some timers offer adjustable hysteresis, which is the difference between the on and off switching points. This can be useful for preventing rapid cycling of the load. Sixthly, consider timers with adjustable delay times for staggered starts or sequential operations. Seventhly, check if the timer allows for adjustable sensitivity to input signals or environmental conditions. Eighthly, look for timers with adjustable output pulse widths for controlling specific devices. Ninthly, consider timers with adjustable reset times for automatic or manual resets. Tenthly, ensure that the timer's adjustability features meet the specific needs of the application. Moreover, the use of relays is an important consideration when the timer's output is not sufficient to handle the load. Firstly, a relay is an electromechanical switch that can be used to control a high-power circuit with a low-power signal. Secondly, the timer can be used to control the relay, which in turn controls the load. Thirdly, choose a relay with a voltage and current rating that is suitable for the load. Fourthly, consider the type of relay needed for the application, such as a single-pole, single-throw SPSD relay or a single-pole, double-throw SPDT relay. Fifthly, check the relay's coil voltage and current requirements to ensure that it is compatible with the timer's output. Sixthly, use a relay socket for easy installation and replacement of the relay. Seventhly, wire the relay according to the manufacturer's instructions and local electrical codes. Eighthly, protect the relay from moisture and environmental factors. Ninthly, regularly inspect the relay for any signs of wear or damage. Tenthly, consider using a solid-state relay for applications that require high switching speeds or long lifespans. Selecting the right timer involves careful consideration of these aspects. The combination of electromechanical and electronic timers offers versatility. Custom timers from electricians can accommodate unique needs. Prioritizing safety and proper wiring techniques ensures optimal performance and longevity.